Hello and welcome to Most Significant Bit, a podcast that explores the connections between engineering, technology, humanities, and the arts. I'm Patrick, and today we're discussing biomimicry and one of the processes used to go from inspired research to the final product. Today's source of inspiration from nature are shells. Not really any shell in particular, but rather the material found in them. Shells and mollusks have been around for a very long time, and you can find them in just about any era of recorded history, whether they're being used for jewelry or other utilities man has deemed them worthy to be used for. Regardless, they've been used a lot. And since man has interacted with shells and mollusks for centuries, it's inevitable that we develop questions about them. Like, why are some shells so hard? Why do some shells have a condensed ball of white beauty in them named pearls? Decades of research has revealed why shells and mollusks are so hard. It is due to a material called nacre, which is a very, very strong material. And just to give you an idea of how strong it is, the University of Michigan and Australia Macquarie's University did an experiment where they put a minuscule protected Mediterranean clam shell under an electron microscope and started to crush it and observe the effects of it being crushed. And what they saw was that under pressure, the shell would disperse everything in it to the areas that weren't under as much pressure. And so you would get something effect like when you're crushing a plastic bag full of water, where your hand is crushing, the water isn't, it just goes everywhere around that. And that's essentially what was happening when you compress the shell that was under the electron microscope. But the most interesting thing was what happened when you started to decrease the pressure and lift it up. Everything would go back together, and the shell was just as strong as it was before. This may not seem important, but this gives nacre a lot of potential, because when you crush plastic, it'll spring back together, but it loses a lot of its strength. And so if we can have a material that doesn't lose its strength after it's been crushed and just comes back together and it's just as strong, then we can upgrade to a lot of the other materials that the Earth has today by taking certain aspects of nacre and applying them to the other materials that are being manufactured today. The way pearls are formed, and you can usually just do research about this and find the answer pretty straight, is that mollusks will have some type of food trapped in them, something that they eat, and they can't really get rid of it. So to protect themselves from any of the parasites or anything that could harm it, they start covering it in the same thing that the shell is made of, which is nacre. And they put layers and layers of this nacre that they can secrete upon the food that's stuck in them, and eventually you get this really hard firm pearl. And that's interesting because that's what we're trying to create. We're kind of trying to find ways to create a new material that could potentially replace metals, concrete, and be used for other applications that could make the world a better place and address a lot of the problems that we have. Now that we know that nacre is a composite made from shells and that uses a brickwork-like structure to be as strong as it is, let's discuss the process that researchers are going to use to go from just being inspired to understanding what it is and sending the end product to solve some of the real-world issues that we have today. Process that's used to go from just being inspired by nature to having that inspiration be able to solve real-world issues that we face today is called NICE, and it stands for Nature-Inspired Chemical Engineering, and it's an off-branch of NIST, which stands for Nature-Inspired Solution. According to the Department of Chemical Engineering and Center for Nature-Inspired Engineering at the University College of London, NIST is a methodology proposed as a systematic platform for innovation and to afford transformative technology required to address grand challenges, including sustainable development. It leverages the universal mechanisms and incorporates them effectively into engineering design, understanding that adaptations may be needed to accommodate the different contexts of nature and engineering applications. Using the NICE method, researchers have found various uses for nacre, and although it's still in its researching phase, they have found that the fundamental brickwork that nature uses to make itself so strong can be used and applied to other materials that we use in everyday life, such as metals and other composites, to increase their strength and flexibility. One of the bigger things that nacre has hopes of being able to replace completely our bones. And the hope is that because the material is so strong yet flexible, it could replace certain bones in the human body, or at least help the biomedical field be able to repair bones at a faster rate than they are able to right now. And of course, they're also looking at prosthetics and being able to increase the flexibility and strength for those too. Overall, there's a lot of potential uses for Nacre and the potential issues it can fix in the world today. Thank you for taking the time to listen to the Most Significant Bit, a podcast that explores the connections between engineering, technology, humanities, and the arts. I'm Patrick, and today you just learned about Nacre, material that's found in shells and mollusks, and how it's going to be used to address some of the real problems that we have today. You also just learned about the methodology that's used to go from being inspired by nature to using that nature inspiration to address the real world problems.